Hi students, today I am going to explain chapter 8 Force and Laws of Motion for class 9 students. So let's see. In the previous chapter we described what is the motion of an object along a straight line. So in terms of its position. So we discussed already what is motion. So how it goes in a straight line and what is velocity, acceleration. So let's discuss briefly. What is speed? We know that speed is the total distance by total time. And what is velocity? So speed plus direction. So when we consider the speed along with its direction, then it is called velocity. And acceleration, how much fastly the velocity is changing. Means the rate of change of velocity is nothing but acceleration. We also saw what is uniform motion, non-uniform motion also. What is uniform motion? The movement of the body in the particular time to the similar distance, same distance traveling in a particular time is uniform motion. And there will be a difference in the distances in a particular time of time. So there will not be same distance covered in the same interval of time. Then it is called non-uniform motion. Like this we discussed in the last chapter motion, and we don't know what is the cause of the motion, how the motion is causing, what is the cause of motion we have not yet discovered. Why does the speed of an object change with the time? So when the time why the speed of the object will be changing. So all these motions definitely require a cause. So what is the nature of this cause? How? So all these questions are answered in this lesson. It's a very important and interesting lesson. So for many centuries, the problem of motion and its causes had puzzled scientists and philosophers. For so many centuries, they don't know what is the cause of the motion, how it is occurring, why the speed is changing. They don't know all this. So a ball on the ground, when given a small hit, it does not move forever. So when we hit a ball, so in the ground, it will be going forever. It will not stop. Yes, no, it will stop after moving for some time. So then, such observations suggest that rest is the natural state of an object. From this we can understand that what is the natural state. So natural state is being at the rest. Then this remind the belief that until Galileo Galilei and Isaac Newton developed an entirely different approach to understand the motion. So they all thought why the ball is stopping, because its natural tendency, natural state is rest. That's why it is stopping, they were thinking. But after that, Galileo Galilei, Isaac Newton, our heroes or scientists, they discovered something newly. What are they? Let's see. In our everyday life, we observe that some effort is required to put a stationary object into motion or to stop a moving object. So when object is there, so already it is moving, then to make it stop, or if it is in rest, to make it move, so we have to apply some force, we have to apply some effort. Yes, no? So we ordinarily experience this is a muscular effort when we push, pull or hit or something. So what happens? It is a muscular effect and it will change the state of the motion. So the concept of force is based on this push. So this push or pull is nothing but force. We know what is force, push or pull of an object is a force. So in fact, nobody tasted it or nobody felt it or experienced it, but we only can explain the force applied to the object by seeing what is happened to that after applying force. Yes, no? So it can be only explained by describing what happens when a force is applied on an object. So when for an object, if we apply force, what happens to it? It will go front, it will go back, or it will stop. What is happening to that object? So that is what we can see. So pushing, hitting and pulling of an object are all the ways of bringing the objects in motion. So all this type of force why we will apply to make the object move. So they move because we make a force act on them. So when we apply force on them, they will move. So from our studies in earlier classes, we also know the fact that a force can be used to change the magnitude of velocity of the object. Not only to make the object move, but also we can make the object move faster or slower, or we can make it to move, change its direction also. So it will also make the change of the shape and size of the object. By applying force, we can change the shape. Yes, no? Spring and ball we can see here. A spring expands and a rubber ball becomes oblong when we apply force on it. So like this. Then next is, what is a balanced force and unbalanced forces? So let's see. So first we take a wooden block on a table, horizontal table. So two threads are tied to that. So one is X, one is Y. If you apply a force by pulling the string X, the block moves to the right. So when we pull, then it will come this side. When we pull this side, Y side, then it will come this side. Yes, now moves to the left. If the block is pulled from both the sides with equal force, then it cannot move because the two forces are balancing each other. Such forces are called balanced force, and because of the balanced force, the state of rest or motion of an object will not change. There will be no change in the state of rest when there are two forces acting in the opposite direction and they are equal forces. So this is balanced force. Now let's consider one more situation. Two opposite forces of different magnitudes. Here X is more force and Y is less force. Then which direction it will move? It will move in the direction of X because more force is acting. So it will move this force. So these the forces are different, means in their magnitude. So when an unbalanced force, this force, different magnitude force is called unbalanced force. When this exists, the block moves in the direction of more force. So this suggests that an unbalanced force acting on the object makes it move, means it will bring its motion. Then, so here see what happens when some children try to push a box on a rough floor. So the floor is very rough. They are trying to push a box. If they push the box with a small force, it will not move. Why? Because on a rough surface, friction will be very more, very more, and it will not allow to move. So the friction force arises between two surfaces in contact. So in this case between the box and the floor. So it will balance. The two forces will balance like in a balanced force. The two forces, pushing force, this is pushing force, and this is frictional force opposite to the direction of motion. Both are balanced. We know that in a balanced force, the object will not move. Yes, no. So no no change in the state of rest or motion. So that's why it will not move. So next, if the children pushes the boxes harder still they are applying more force, so that it is more than the frictional force. It is more. So pushing force is more than the frictional force. Then it is unbalanced force. Yes, no. This force is more than frictional force. Then the box will move front in the which direction they are applying the force. So it is an example of unbalanced force. Next, what happens when we ride a bicycle? So when we are riding a bicycle, we stop pedaling. What happens? The cycle will get slowed down and after that it will stop. Again, why? Because friction force is acting opposite to the direction of motion. So in order to keep moving, what we have to do? We have to start pedaling again and we have to continue its pedaling. So it is thus that an object maintains its motion under the continuous application of unbalanced force. So this unbalanced force should be continuously applied to make the body move. However, it is quite incorrect. Why? Because an object moves with uniform velocity when the forces acting on the object are balanced and there is no external force. So what happens? So the velocity of the body acting on the object if we are giving a balanced force and no external force is given, then it will be moving in a uniform velocity. So if an unbalanced force is applied, so we are not giving balanced force. If we are giving unbalanced force, then it will make it to speed up or change the direction of motion. So to accelerate the motion of an object, so we want unbalanced force to change its speed. Yes, no, or direction of motion would continue as long as we are giving unbalanced force. So however, if the force is removed completely, if we are removing the force completely, what happens? The object would continue to move with the velocity it has acquired till then. For example, one girl, small baby, is sitting in a swing. We are pushing the swing. So when we stop also, it will be moving for some time and later it slows down and stop. So the velocity which is acquired by giving some force before, it will act for some time. That is what they told. Then next is first law of motion. So what is the first law of motion? By observing the motion of objects on an inclined plane. So they observed the object's motion in an inclined plane. So Galileo detected that objects move with a constant speed when no force acts on them. So the objects will be moving with a very same speed, constant speed, when force is not given to them. So he observed that when a marble rolls down on an inclined plane, its velocity increases. So this because we know that it is under the gravity. In the gravity lesson we will discuss. So next, so marble falls under the unbalanced force of gravity as it rolls down and attains a definite velocity by the time it reaches the bottom. So it rolls down here and comes down and it will acquire some definite velocity. When it reaches bottom, its velocity decreases when it climbs up. Again, when it climbs up, its velocity decreases. So when it comes down, its velocity increases because of gravity. Again, when it is going up, its velocity decreases. So then, so 8.5c, so see this one, shows a marble resting on an ideal frictionless plane. So no friction for this plane. So ideal plane inclined on both the sides. Galileo argued that when a marble is released from left, so when a marble is released from the left, it would roll down the slope and go up the opposite side to the same height from which it is released. So from which height we release, that much height it should reach. Yes, no? Then if the inclination of the plane on both sides are equal, then marble will climb the same distance it covered when rolling down. If the angle of inclination of the right side plane is gradually decreased, when the inclination is gradually decreasing, when the inclination is same, the same distance it will cover. When the inclination we changed, we decreased it, then what happens? Then the marble will travel for the distances till it reaches the original height. It will be traveling until it reaches to the original height. From that height we pass it the marble. So from this, if we keep it in a right angle, so then it will be traveling continuously, so without stopping. So is it possible? So no. The marble would continue to travel forever trying to reach the same height then it was released from. So the unbalanced force on the marble in this cases are 0. It thus suggests that unbalanced force is required to change the motion of the marble, but no net force is needed to sustain the uniform motion of the marble. So what they are telling is, so we want unbalanced force to change the motion of the object. If we want the same motion, uniform motion, no need of unbalanced force. Yes, no. This is because the presence of frictional force. We know that frictional force is also acting on the marble after traveling some distance. So because of this frictional force, it will stop. Yes, no. But this frictional force can be minimized by using a smooth marble and a smooth plane and we can even add a lubricant on the top of the plane. So like this we can decrease the friction by using like this, so that we can found. So by seeing all this, Newton got a new idea. So Newton further studied these Galileo's ideas on force and motion, and he presented 3 laws of motion. So the 3 laws are called Newton's laws of motion. So first law I am telling, an object remains in a state of rest or of uniform motion in a straight line unless compelled to change that state by an applied force. So when we take one object, it want to be in a rest, or when it is moving in a uniform motion, it want to move in that uniform only. So it does not want to change. When we resist to change, when we compel to change, when we want to change its motion from rest to moving or uniform motion to more speed, then what we have to give? We have to give some force, that is applied force. So no object want to change its state of motion. It want to be in rest or in uniform, if it is already moving in the uniform motion. Only if a force is applied, then it will be changing its motion. So an object cannot move by itself, no. It will be in its state of motion only until we give some force. So this is, so in other words, all objects resist a change. Every object don't want to change the state of motion. Yes, no. So in a qualitative way, the tendency of undisturbed objects to stay at rest. The objects want to be in a undisturbed, when we are not disturbing it, it want to be at rest or keep moving with some velocity. And this property is called inertia. What is inertia? Every object don't want to change. Don't write like this. I'm explaining like this. So every object don't want to change its state of rest or motion. It want to be how it is. But when we apply some force only, it will change. So the object, the tendency of this object to stay in that state only, the rest are keep moving same velocity, it is called inertia. That's why this first law of motion is called law of inertia also. Yes, no. For example, certain examples I will tell. Yes, no. While traveling in a motor car, we are traveling in a motor car. So we tend to remain at rest with respect to the seat until the driver applies a braking force. So we are traveling in a car, we are sitting comfortably, we are in rest. Then sudden brakes applied. With the application of the brakes, what happens? The car slows down. But our body want to maintain the same state of motion. It don't want to change its state of motion because it is in inertia. So sudden application of brakes, what happens? May cause injury to us. Why? Because we will collide with the front panels of the car. So safety belts are worn. That's why to prevent these accidents. So safety belts, what it will do? It will exert a force on our body. So and it will stop moving slower, or it makes our motion slow, so that we will not collide or collision with the front part. So we will not beat up with the front part. And next, one more example. We are standing in a bus and the bus suddenly beginned. What? We will tend to fall backwards. Yes, no. Why? Because the sudden start of the bus brings motion to the bus. After sudden start of the bus starts moving, as well as our feet in contact with the floor on the bus. So the bus, our feet is in contact in the bus. It also wants to move front, but our body, it is in rest. It wants to be in rest only. So it will opposes that motion. Because of this inertia, we will fall backwards. Then, when a motor car, we are going in a motor car. So suddenly we have to turn to the next turn. So we took a sharp turn, a high speed. What happens? We will be thrown to one side. We will bend one side. Yes, no? How? Same, like inertia only. So we are going in a straight line motion. So we want to be in that only. We don't want to change the direction or its velocity or acceleration. Nothing we want to change. We want to be on the same motion. So on the basis of inertia, we tend to continue in our straight line motion only. So when unbalanced force is applied on the engine to change the direction of the motor car. So due to the inertia of our body, means we want to be in the same state of motion of our body. So we will slip to one side of the seat. So these are all the examples of inertia and first law of motion. The fact that a body will remain at rest unless acted by an unbalanced force. So from this we can conclude the first law of motion. Every body want to be in rest unless acted by some force, that is unbalanced force. So one more example they gave here. So while playing carom board, we keep all the black coins, see, one by one, and with the striker we will just bid the bottom coin. What happens if we bid correctly? It will go and fall in the inside. Or when it is just moved, when we want to remove that striker from here, yes, no, then all the coins will fall down, yes, no, vertically on the table. So lowest coin is removed, the inertia of the other coins makes them fall, because that other coins don't want to move, they want to stay there only. The object tend to be in the rest only. So when we are giving force, then it will fall down. So this is one more example and one more activity. So take a glass tumbler, just place a stiff card on that 5 rupees coin and just move the card a sharp horizontal flick with a finger. So what we'll see? We'll see that 5 rupee coin will be falling inside. Yes, no. So the inertia of the coin tries to maintain its state of rest. That coin don't want to move. It want to maintain its state of rest. Even when the card flows off also, it don't want to move. So that's why it will fall inside. So these are the examples of inertia. So I told so many examples of inertia. So then what is inertia? Yes, no. So all the examples and activities given so far illustrate that there is a resistance offered by an object to change its state of motion. So to change its state of motion, object resists. So if it is at rest, it wants to be at rest. If it is moving, it wants to be moving. So this property is called inertia, and every body will have same inertia. For example, we'll see. To push an empty box and to push a box full of books, which is easy? To push an empty box, right? And again, if we kick a football, it will fly away. Take same size of a stone. Is it easy? No. It is not that much easy as a ball. Yes, no. And even we will get injury also with the stone hit to us. Yes, no. Even a 5 rupees coin, if we use a 1 rupee coin. So we find that a lesser force is required to perform this activity. This activity with a 5 rupees coin and 1 rupee coin, which is easy. Yes, no. 1 rupee coin. Yes, no. So from this what we can understand? Its mass is more important. So we may conclude that inertia and mass, they have one relationship. Yes, no. So inertia is the natural tendency of an object to resist a change in its state of motion or of rest, and the mass of an object is the measure of its inertia. So we can measure the inertia with the help of its mass. For example, the questions given here, see. Which of the following has more inertia? A rubber ball and a stone of same size. Which has more weight? Stone. That's why more inertia. A bicycle and a train. Which has more mass? Train. That's why more inertia. 5 rupee coin and a 1 rupee coin. Which has more mass? 5 rupee coin. So like this, we can conclude the Newton's first law of motion. I think it is very easy. Next is second law of motion. So the first law of motion already told, when we apply a balanced force, then only it will move, or else it will not move. Yes, no. Then that is, the object gets an acceleration. We would now like to study how the acceleration of the object depends on the force. I already told the acceleration will be changed when we put some force. So how this force acceleration, how it will change, what is the connection between them? Let us see with some examples. So during the game of table tennis, we are playing a game of table tennis. If the ball hits a player, it will not hurt. When we are seeing a cricket, a spectator, if a ball hits him, it will hurt him. Yes, no? A truck. So, for example, a truck is at rest. It is not moving, it is at rest. Now, we don't need to pay attention on that. Yes, no? So, it is parked on the roadside. So, it will not harm anyone or anything. But a moving truck, even it is going in a very, very low speed as 5 meters per second, it may kill a person. Means a small mass such as bullet, yes, no, from a gun, even it will kill a person. So, from all these examples, what is the connection between all these? Yes, no. So, we will get one idea. There is a relationship between mass and velocity. Between mass and velocity. So, we know that a greater force is required to give a greater velocity. To have more velocity, more force should be there. So, in other words, that appear to exist some quantity of importance that combines the object's mass and its velocity. So, we want both mass and its velocity, and that is nothing but momentum. It is given by P, that is equal to product of mass and velocity. So, momentum, it is a vector quantity. It has both direction and magnitude. Its direction is same as that of velocity. In which direction we are applying velocity, in that direction only it will move. And what is its SI unit? Momentum. P is equal to mv. So m is kg and v is velocity meter per second. So kg meter per second is the momentum's SI unit. So since the application of unbalanced force brings a change in the velocity of the object, it is therefore clear that a force also produces a change in momentum. So when we apply a force, unbalanced force, then what happens? It will change the momentum of the object. So for example, change in momentum we will take. So change in momentum is proportional to, so P2 minus P1, change in momentum, initial momentum, final momentum. Initial momentum, first momentum is P1 is equal to mu, because u is the initial velocity, and P2 final momentum m into v. V is the final velocity. So change in momentum is proportional to P2 minus P1. So final minus initial momentum. So mv minus mu, m is common. So m into v minus u. So rate of change of momentum. So time, here rate means how much fast in the particular time. So we take time also in the consideration. So m into v minus u by t. So all this occurs because we apply force only. So that's why force is proportional to m into v minus u by t. We know that. So when we take proportion, we should take constant. So F is equal to K m into v minus u by 2. We know that acceleration is equal to final velocity minus initial velocity by time. So yeah. So F is equal to K ma. If we think K is constant and it is 1, then F is equal to ma. Yes, no? Like this we can derive the equation for the force. And ma, what is its SI unit? M is mass, kg. Yeah, acceleration A is meter per second square. So kg meter per second square. Or because it is discovered by Newton, this force, so it is called Newton and given a symbol capital N. So from this we can conclude what is the second law of motion. Gives a method to measure the force of acting on an object to produce a product of its mass and acceleration. So second law of motion tells how we have to measure a force. Force can be measured by the product of mass and acceleration. So second law of motion is often seen in action in everyday life, like first law of motion. So for example, we are watching cricket. So we see while catching a fast moving cricket ball, the fielder will bend back. Yes, no? So to catch that, why he will bend back? Because to increase the time. With when he increases the time, the ball slowly slows down and it will not hurt him. Yes, no? So in hands backwards with the moving ball. In doing so, what happens? The fielder increases the time. So during which the higher velocity of the moving ball decreases to 0. That's why the acceleration of the ball is decreased and the impact of catching the fast moving ball also reduced. If he didn't bend backwards, ball is stopped suddenly with high velocity and to zero in his hands only. What happens? He will get hurt. Yes, no. So zero in a very short interval of time. Thus the rate of change of moment of ball will be very large. Therefore, when the rate of change of momentum of ball is large, more forces have to be applied for holding it or catching it, and it may harm the palm of the fielder. So next, in a high jump athletic, we can see events. The athletes are made to fall in a cushioned bed or a sand bed. Here also, to make the increase of the time, the athletes will fall to stop after making the jump to decrease their change of momentum. So the force will be reduced so that they will not get hurt. That's why like this they are produced. So this is the applications of second law of motion. So by combining first to second law, we can easily tell. So until we apply force, no body want to be move or change its state of motion, and that force is nothing but ma. What is that? M, mass into acceleration, or m into v minus u by t. So when we take t this side, ft is equal to mv minus mu. So when f is 0, we are not applying any force. Then what happens? V is equal to u. Means initial velocity is same, final velocity also same. If it is same, then it is not moving anything. So the net moment is 0. Means if you are not giving any force, then there will be no moment. So first law is proved. Yes, no, with the second law, first law is also proved. So that is about second law. And last is very easy one is third law. So first two laws tells how the applied force changes the motion and provides with a method of determining the force also. But third law, when object exerts a force on another object. So when one object is exerting a force on the other object, the second object also gives some force to the first object. So these two forces will be equal in magnitude, but they will be in a opposite direction. So for example, in the game of football, sometimes we while looking at the football and trying to kick it with a greater force, collide with a player of the opposite team, but both feel hurt. For example, so if we are beating one another, so if we collide with one another, both will get hurt. Means one body will exert a force on the other body, that other body also will exert on the first body. So the two forces will be same force and opposite direction. So what is our third law? Very easy. For every action there will be a equal and opposite reaction. So for so I am concluding it with the two examples here. So see, take two strings, spring balances. So one is tied, yes, no, with a fixed end, another we are pulling it, so that here a force is created, and this will create the force on this, and this also creates force on this. Both will show the same reading. So this is the one example, and one more. See, when we apply when a gun is fired, it exerts a forward force on the bullet. So the bullet exerts an equal and opposite force on the gun also. This results in the recoil of the gun. Since the gun will have much greater mass than the bullet, acceleration of the gun is much less. But the acceleration of the bullet is, because it have very small mass, the acceleration is more. That's why it will go very fastly and kill a person. So third law of motion, like this we can illustrate. One more example also they gave. See, when a person as a sailor jumps forward, the force on the boat moves it backwards. So when he is jumping front, this one will move back. So both have force. Two forces are acting. So like this we can conclude the third law of motion. Thank you.